Okay, lesson 28, take 2. For those of you who are watching me live, you saw me make a terrible mistake. I taught an entire lesson and then it wasn't recorded. So we're going to do it again. Hopefully this time it's better. Again, 8M4, lesson 28. Another computational method of solving a linear system. This implies that you already know one method of solving a linear system. And yes, there are at least 2 that we've taught you so far. The first one is graphing. We solved systems of equations by graphing. The second form was that we solved in lesson 27. We learned this skill in lesson 27 was how to solve an equation using substitution. So let's look and find the other way, another way of doing it. So this is going to be called elimination, but we'll worry about that in a second. I'll write that down, elimination. But in lesson 27, we solved using substitution. So we used a building block, we used a building block from, it's either 5th or 6th grade. And that is that we knew that if something equaled something, and that same thing equaled something else, so if these two were equal, if A equals B and A equals C, then B also equals C. Then these two had to be equal. A couldn't be equal to B and then A equal to A, but not equal to C. They all have to be equal to each other. So what we did is we used this building block from 2 years ago, and we said that we can use that to solve very complicated equations. Look at this. So we said if y is equal to 2x plus 4 and y is equal to 3x minus 7, then 2x plus 4 equals 3x minus 7. And then we could go about using our 7th grade algebra techniques, our 7th grade skills to solve for x. So we could go about solving for x, and then we could continue our 7th grade skills and come back and take our answer and then solve for y. Okay, we can remember that from lesson 27. Similarly, sometimes, and you're going to use a building block like this here in lesson 28, is sometimes our substitution wasn't perfect because our 2y wasn't equal to our y, so we couldn't substitute directly. But we could say, well, let's take this second equation and multiply by 2, and we get 2y equals 6x plus 8, because we'd take that 2 and would multiply it by our entire equation. And now we had 2y equals x minus 3, and we'd have 2y equals 6x plus 8. So now we could make these two equal and then go about solving our equation and then solve for x and y, dot, 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 dot. Okay? We're going to use a similar trick, this multiplication trick here in elimination as well. So keep your eyes open for that. So lesson 27 used this property: if A equals B and A equals C, then B equals C. The property that we're going to use in lesson 28 over and over again is that if A equals B, so we have a scale here, and we have A and B are equal to each other. And then if C equals D, so we have another scale where C and D don't have to be the same as A and B, but they do have to be equal. We can take these two things and put them on the left side of a scale, and these two things and put them on the right side of a scale, and they're still equal. Right? Those things better be equal when you sit them on top of a scale. Because if I have an apple over here and an apple over here, and I have 2 pears over here, and I have 2 equal-sized pears over here, I should be able to put the apple and 2 pears together on the left and the apple and 2 pears on the right, and everything should still be equal. All right, that's kind of like the high level. So let's make that a little bit more specific, and let's see how we apply this to lesson 28 to solve equations linear systems, right? So again, you take the left, if two things are equal and then two other things are equal, I can take the two left sides and say that those are equal to the two right sides, and that's still true. So let's do that here. So I'm going to add my left sides together, and then I'm going to add my right sides together, and then we're going to see how that helps us solve this equation. So from the scale perspective, I have x plus 2y equaling 3. And then on another scale, I have 2x minus 2y equals 6. And I can just take all of this together and all of this together and stick them on a brand new scale. And those things better be equal. So let's add these down. And we've done this adding down thing. Like when we've solved equations like 2x minus 7 equals 10, and then we've had, we've added 7 to both sides. You add down 2x, these things cancel, equals 17. We've done problems like that. So this is not a new technique or a new strategy. It is a new strategy on solving these types of equations, but it's not a new property. So when we add our x's together, we get 3x. And when we add our y's together, look what happens. Positive 2y and negative 2y, those things cancel. So we get 3x equals 9. And so the whole idea here is that we eliminate one variable when we add down. That's why this thing is called elimination. And so now I can say x equals 3. And now we're working in the same, now we're solving the same way that we solved when we did substitution. We're going to take our x and we're going to plug it back in here to solve for our y. So we have, x plus 2y equals 3. So I'm going to put my 3 in for x. So 3 plus 2y equals 3. Subtract 3 from both sides. 2y equals 0, so y equals 0. Now we're going to check our answer with our second equation. So 2x minus 2y equals 6. So we're going to plug our 3 in here and our 0 in for y. And we're going to say, well, does 2 times 3 minus 2 times 0 equals 6? And the answer is 6 minus 0 equals 6. So we get a nice happy cat. Because indeed, our check step does check out. Okay. Now our second equation is going to be a little bit more complicated. We're going to use a technique that we used earlier on our when we did elimination. Now here, notice what happens. We're going to try and add down. But what happens if we add down here and we add down here? We just get a new equation that says x plus 5y equals 11. And we haven't eliminated the x or the y because we don't have coefficients that are additive inverses. So we're going to use a trick where we multiply one of our equations by a magic number that will help us eliminate the x value. So what can I multiply this bottom by to get to a number that when I add it to 2x, it will be eliminated? I want this to be a negative 2. So what do I need to multiply this bottom by? Question, what to multiply bottom equation by to eliminate x? Well, it's a 2. Because if I multiply this bottom one by a 2, it'll then match this positive 2. So we get negative 2x plus 4y equals 6. Can I multiply my 2 by all of my terms? Now I'll take my top equation and rewrite it here. 2x plus 6y, 3y equals 8. And now when I add down, these guys will be eliminated. And I get 7y equals 14. And then y equals 2. Are we done? No. We need to substitute our y into our top equation. So 2x plus 3 times 2 equals 8. 2x plus 6 equals 8. Minus 6 minus 6. 2x equals 2. And then x equals 1. So our answer is 1 comma 2. We're going to substitute into our second equation to check. This is our check step. So negative, well, I'll just rewrite it. Negative x plus 2y equals 3. So negative 1, we're going to plug this in, plus 2 times 2 equals 3. Negative 1 plus 4 equals 3. So 3 equals 3. Happy cat. Well done. We solved it by elimination. One more level of difficulty, and we'll do that one right now, is sometimes you have to multiply, and I'll give you the hint here again, you have to multiply both equations by a number, by a different number. Okay, so here we go. So I'm going to multiply the top. So notice if I add down, these don't match and these don't match. So I'm not going to get either one of these to eliminate. So I need to get the top and bottom. And I can't, there's no number I can multiply 2 by to get to 5. And there's no number I can multiply 3 by to get to 4. So there's not one number I can multiply top or bottom by to make things eliminate. So you think you're kind of stuck. But the answer is no. You're not stuck, because the trick is to multiply the bottom. But if we want to eliminate, let's just say we want to eliminate x. And I want to eliminate x. I need to multiply the top by the bottom coefficient of x and the bottom by the top coefficient of x. And watch why that works. Because now I get a 2 times 5, and on the bottom I get a 5 times 2, and then I'll get the same number. But we won't be quite there. So let's just see what happens when I do this, though. I get 10x plus 6y equals 4. And I multiply this one by 2. I'm going to multiply this bottom one by 5. And I get 10x minus 20y equals 30. Well, if I add down, these don't eliminate and these don't eliminate, but I do have the matching coefficient. What should I have done? Well, if the key is if these have if they're both positive, then I have to multiply the bottom one by a negative number. So we're going to, instead of multiplying by 5, we're going to multiply by negative 5. And then we'll get the elimination. Negative 10x plus 20y equals negative 30. Now these will eliminate when I add down. So I get 26y equals negative 26. So y is equal to negative 1. So checking my work, solving for x, I get 5x plus 3 times my y, negative 1 equals 2. 5x minus 3 equals 2. 5x equals 5 because I added 3 to both sides. So x equals 1. So my answer is 1 comma negative 1. And I'm going to do my check step on the second equation. 2x minus 4y equals 6. So 2 times 1 minus 4 times negative 1 equals 6. It says better be true. And it is true. There's my happy cat. All right. One more point that I'd like to make. Sometimes you're going to have problems, and let me show you one last. I'm just going to show it to you here. We'll show it to you right on the same screen. Sometimes you're gonna your equations aren't going to line up exactly. So let's look at an example of what I'm talking about. So sometimes you get a problem that says like y equals 2x plus 4, and then you'll get another on the bottom. You'll get like, x plus y, or no, let's do it like this. X plus 2y equals 8. Well, in this equation, I don't have my stuff, my variables aren't lined up. So you can't use elimination unless your variables are lined up. So I need to get my x's and my y's all in the same spot. So I'm going to, on this top one, what I'm going to do is I'm going to get my x's lined up, and my x's and y's on the left, and my 4 and my constant on the right. So watch how I do that. So we're going to take our y equals 2x plus 4. I'm going to subtract 2x from both sides. 2x plus y equals 4. And now, if I line them up, now I can start to talk about what I want to do to solve this equation. Because now I can see that these won't eliminate and these won't eliminate. But I can multiply the top, in this case, by 2. And then I get 2x plus 4y equals 16. And then I can go about solving, because these now eliminate. I get 5y equals 20. Y equals 4. And then I can go back and continue solving. So again, the key is sometimes if my variable, and you're going to have some problems like this on your homework where the variables don't line up. And the key is to get your x's and y's lined up and your constant lined up to solve that type of problem. Okay, so let's go straight now to homework help. And on this homework help, I have what I call simple elimination, multiply by one equation by a number, and then we're going to multiply both equations by a number on this last one. So this was like my first example today. This was like my second, and this was my third example. So now I'm going to let you pause and try. And I know this is a lot. This lesson ought to be 2 lessons, 2 days worth of lessons, and lots of practice. You're going to have homework, I think 15 homework problems, and really you need to grit through them and really persevere and to introduce this skill into your knowledge bank. Okay, now I assume you've paused and tried. So now the simple elimination, we can just add down, because we know when we add down, we're going to eliminate x's. So if we add down, we get 2y equals 10, y equals 5. So let's substitute back into this first equation. So negative x plus 5 times 5 equals 3. Negative x plus 25 equals 3. Subtract 25, subtract 25, negative x equals negative 22, so x equals 22. And then substitute. Now we know that y is 5 and x is 22, so let's substitute into the second equation to verify that we have the right answer. And indeed, it looks like we do, because 22 minus 15 does equal 7. And that's a happy cat. Wrap it up. All right. This one we need to multiply by 1. Well, which is the one that we need to multiply? Well, we can't multiply 2 by anything to get to 5, so it must be this half that we need to multiply. And the answer is yes, we need to multiply this top one by 2. So then we get 2 times a half is just x. 2, this is 4y. and then 2 times 10 is 20. So now if we add down, those disappear, and we get 9y equals, I did it again. I can't believe I did this again. Okay, this should have been a -2. I'm going to fix that on the video. -2. So this, when we add this down, 18. Sorry. We'll fix this when we post it. So y equals 2. So now we're going to come back into our original equation here, and we're going to put a 2 in for y, and we get our half x plus 2 times 2 equals 10. So half x plus 4 equals 10. So half x equals 6. So x equals 12. We'll do our check on our second equation here. So -12 plus 5 times 2 equals -2. So -12 plus 10 equals -2. -2 equals -2. Check. Happy cat. On this last one, we want to eliminate, we'll eliminate x's. So we'll multiply our top by the bottom coefficient of x, and our top by the bottom, bottom equation by the top coefficient of x, and we're going to use a -3. Remember, because they're both positive, one of these has to be negative and positive so that we get the correct elimination. So let's see. 12x minus 8y equals 32. And on the bottom, we get -12x plus 15y equals -18. Add down, we get 7y equals 14. Okay. And y equals 2. Substitute into this first equation. We're not going to use these complicated equations over here to substitute. We want to substitute back into the original equation. So we get 3x minus 2 times 2 equals 8. So 3x minus 4 equals 8. So 3x equals 12. X equals 4. 4 comma 2 is our answer. And let's check on our last equation, our second equation. And we get 4 times 4 minus 5 times 2 equals 6. Does 16 minus 10 equal 6? It sure, happy cat, does. Okay, this has been pretty, this is tricky stuff. This is a very, we're near the end of the lesson. We're near the end of the unit, and this stuff is difficult. There's a lot of moving parts, so you need a lot of practice on this stuff. So hopefully this is something that you work hard at. It's up to you to make the decision about whether you want to be the master of algebra or whether you want to not work so hard when it gets hard. But I say when the going gets tough, the tough get going. This is all learnable. And we got one more homework problem, actually. And that's this, this problem here. So this is the way that a lot of the homework is. It says, let's solve, but check by graphing, which is weird, but we're going to solve and we're going to check by graphing. So a couple lessons ago, we solved using graphing and we checked with algebra. Now we're going to solve with algebra and then check by graphing. Now, these equations aren't written. Let's solve by elimination. Let's solve by elimination. So let's get our x's and y's on the left. 2x plus y equals 6. And over here, let's get, negative x plus 3y equals -3. So now it's set up to solve by, sorry, not elimination, substitution. Elimination. What am I saying? So by elimination, so we can't eliminate these guys, nor can we eliminate these guys. But we can multiply this bottom one by 2. So let's do that. So I'm going to rewrite the top one, and we're multiplying the bottom one by 2. Let's add down 7y equals 0. Oh, nice. So y equals 0. Substitute back into this first equation to get our x. Two x equals 6, so x equals 3. So our answer is 3, 0. Now, rather than check by substituting into this equation, we're going to solve by graphing. So let's do that. So we better get what? We better get 2 lines that cross right here at 3, 0. Better happen, or we didn't do it right. So let's look. This first equation, y equals negative 2x plus 6, is in graphing format. M equals negative 2, which is rise over run, negative 2 over 1. And our b is equal to 6. So our b is equal to 6. Our y-intercept is 6. And we go down 2 over 1. Our slope is down 2 over 1, down 2 over 1. Looks good. Looking good. Okay, so we're good so far. Now we got to do our other equation, and we'll do that one in green. So 3y equals x minus 3. Well, this isn't in graphing format because there's a coefficient in front of our y. We need this to be in y equals mx plus b format, which we know how to do. So let's divide everything by 3. And now we have y equals 1/3 x minus 1. Our m is equal to negative 1/3, and our b is equal to negative 1. B is negative 1, so positive 1/3. That's positive. There's no negative there. So positive 1/3. So we go up 1 over 3, up 1 over 3, up 1 over 3, and there you have it. You indeed have a line that crosses at 2 lines that cross at 3, 0. So the system of equations by graphing shows that our answer is 3, 0. By algebra, it's 3, 0, and that deserves a happy cat and a happy cat. So we are done. We are done with today's lesson. So hope you stuck with it. Again, this is getting to the end. So if you stuck with it, and you practice, I've given you 6, 7 examples of how you do these problems. And if you use that same method when you're solving equations, doing your homework, you should have no problem. On the homework, there will be some fractions. I didn't give any fraction problems today, but there will be a few that are. So don't fret if your answers aren't working out perfectly. Those fractions probably are the right answer. So hopefully this was helpful. We'll be back with lesson 29 tomorrow, and keep up the good work.